Hello everyone. So today let's solve the problem 518 coin change 2, right? So let's see what the question states here, right? So here we are given coins of different denominations and a total amount. See here we are given coins of different denominations. See this one, sorry, coins 1, 2, 5 we have been given, and we have been given coins this one coins of different denominations and a total amount, right? So what we need to do, we need to return the number of combinations to make up that amount. Again, we need to return the number of combinations to make up that amount. We can use each coin infinitely, or we have to return 0 if no combination can make the amount. We can use each coin infinitely, right? We can just make use of these coins infinitely. We have to return 0 if no combination can make up that amount, right? So see here, in this case we have been given 1 to 5 and the amount we have been given 5, right? So here we can just make use of 5 1 rupee coins. Suppose let's consider this one in the form of rupees, so this will be 5 1 rupee coin we can go with, or 2 1 rupee coin and 1 rupee coin, right? That also we can do, and two this one 2 rupee coin and 1 3 rupee, this one, what do we call, 3 1 rupee coins. Yeah, so this is also one of the combinations, and we can just go with one coin that is nothing but 1 5 rupees coin, right? So this is fine. So these are the combinations. Total we have 4 ways to make up the amount. So we will return output 4. Next, let's go with the example 2. We have amount equals 3 and coins equals 2, right? So output that we have here is 0. See, the amount of 3 cannot be made up just with the coins of 2, right? So see here, amount we have 3 and the coins we have 2. So we will be going with the multiplication of the 2, sorry, addition of the 2, actually 2 plus 2 4 4 2 6 6. It will not be 3 in any way, right? So this one, the amount of 3 cannot be made up just with the coins of 2. So in that case we have to return 0. See, we have coins amount 10 and the coin we have is 10, so 1. So we can just this one, what do we call, we can just go with 1 10 rupee coin that makes up to this amount, right? So this is fine. The output we need to, there is only one way, right? So we have to return the output 1. So this is fine. They have given us wonderful examples just for the sake of understanding, right? So now let's do one thing. Before writing the code, let's discuss the approach followed by the complexities, right? So first I want to tell you that we will be making use of the dynamic programming to solve this particular problem. So we will be going with a 2D DP, 2D dynamic programming to solve this problem. The first step here would be, let's consider the same first example, man. So this is simple, and we can consider this one, right? So we can just I can just show you an easy way, basically, right? So this is fine. So we'll be, first step here, we will be making use of the 2D DP table, nothing but DP of ij here, DP of ij, that is equivalent to the, that is equivalent, where I is the number of coins considered and j is nothing but the amount, where I is number of coins and j is nothing but number of this one amount, sorry. Second step, dp of ij is nothing but number of ways to make the amount j using first I coins, right? First I coins. Here the base case will be dp of I 0, dp of I 0 equals 1. So this is going to be the base case, because see, dp of I 0 will be equivalent to 1 because 0 amount can always be made with 0 coins, right? So this is the base case. So there will be one way, 0 amount can always be made with 0 coins, right? So there will be one way. So this one initially will be go with a base case, this base case, right? So this is fine. Next, let's go with the third one, this one. Let's move on with the third step here. Let's see the transition here. If we don't take the 8th coin, then we can just write it in this way. dp of ij, dp of ij is equivalent to the dp of I minus 1j, dp of I minus 1j. So this is fine. Yeah. Next, this one, if we take the 8th coin, then we can just write it in this way. dp of ij, dp of ij. So this one, dp of ij equals dp of ij plus dp of I j minus this one, what do we call, coins of coins of I minus 1, coins of I minus 1. So this is fine. Yeah. Now let's move on with the fourth step. This is fine. Sorry. Yeah, let's move on with the fourth step. We are done with the third step, right? So this is fine. Now we have to fill the DP table row by row. Now we have to fill the DP table row by row. Let's consider the same example here. This one. So first, we will be going with DP of one, uh, DP of one from 1 to 5 here. Actually, yeah, we are going with a 2 DP, right? So this will be using one coins, using one coins actually, using coin one. This one we are considering. So ways are 1, 1, 1, 5 ones, right? So this is first thing. The second coin here would second way here would be DP of 2 from actually 2 to 5. Sorry, from 1 to 5 itself. We have 2 from 1 to 5. This way we can consider, right? So this one using coins 1 and 2. We will be making using we'll be using the coins 1 and 2 both, right? So the combination, the ways are here 2 actually. With 2 ways it would be this one ways 1, 2, 2, 3, 3. So we are representing this one in the form of table. This one, 1, 2, 2, 3, right? So this will be 3. Uh, Accordingly with this one. Finally, we'll go with a DP of 3, DP of 3 from 1 to 5. In this case, we will be making use of uh, all the 3 coins here. Whatever they have given in the input, we'll be making use of the coins 1, we'll be making use of the coins 2, as well as we'll be making use of the coins 5, these 3 coins, right? So we'll be adding the combinations with 5. There are 4 ways for the amount 5. There are 4 ways for the amount 5, right? So all the 4 ways, these 4 ways actually. Yeah, there are 4 ways for the amount 5. So here, this one, what do we call? The output that we got here is 4 actually. The output that we got here is 4, which is equivalent to the output that they have given for the example 1 within the question, right? As we are completely familiar with the question, sorry, as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part, right? So finally, what we'll do before the complexities part, so we got here this one, 4 ways, right? So we will be returning DP of this one. Sorry, what do we call? Coins dot length actually, coins dot length, DP of coins dot length uh, and amount actually, DP of coins dot length and amount. So this one we will return this one to 4, right? So this will return this one to 4, right? The value that we got 4, right? So we'll return this one 4, right? So the output that we got here is 4, which is equivalent to the output that they have mentioned for the example 1 within the question. This is fine, man. Now let's do one thing. As we are completely familiar with the approach and the complex this one approach part, let's move on with the complexities part. So what will be the time complexity here? Quite obviously you would have guessed already, this will be n into amount, right? So why it is n into amount, we know that we'll be iterating over all the coins and all the amounts, right? So overall time complexity would lead to because n into amount. So what will be the space complexity here? Space complexity would lead to because n into amount again. So why it is big of n into amount? Because we'll be going with a 2D DP table of size coins dot length plus 1 into amount plus 1. We have discussed this one already. Overall space complexity would lead to big of n into amount as well. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n into amount and big of n into amount respectively, right? As we are completely familiar with the approach and the complexities, let's start writing the code. Let's start writing the code, right? So this is fine. Now, first I'll be making use of the coins dot length of the coins everywhere. So let me assign this one to the variable n instead, right? So that we can make use of the variable n. So I'll just give here coins dot length. So this is fine. Next, we have x number of ways, right, to make the amount j using first I coin. So first let's do one thing. Let's initialize the DP array. So we as I've said, we'll be making use of the 2D DP, right? So this one will be DP equals new int of n plus 1 into this one amount plus 1. Yep, this is simple, man. Now let's do one thing. Let's go with a base case. Zero amount can always be made by taking 0 coins, right? Let's move on with the iteration part. So this one will be int I equals 0, I less than or equal to n. So this will be I plus plus. So within the for loop, let me go with the DP of I 0 equivalent to 1. Yeah, this is fine. Now let's fill the DP table. Let's move on with the for loop. So this one will be for int I equals 1, I less than or equal to n. So I plus plus. So this is for each coin. Now for we have to consider for each amount as well. So let me go with one more for loop here, nested for loop, right? So this one will be int j equals 1, j less than or equal to, we are considering for the amount. So this one will be j plus plus. So within this for loop, so we uh, we don't take the coin, right? Then uh, there are two these things we have considered. There are two criteria. One is not taking the coin or don't take the coin. The second one is take the coin if the amount allows. These two conditions. When we do not take the coin or don't take the coin, so that condition I can just write it in this way: dp of ij. So this is equivalent to dp of I minus 1 j, right? So this is fine. Next one is this one: take the coin if the amount allows. So I can just write it in this way. Let me write the if condition itself. This can be written like j minus coins of I minus 1. This is fine. If it is greater than or equal to 0, then let me go with dp of ij uh, equals dp of ij plus uh, dp of I into j minus coins of I minus 1 of I minus 1. So this is fine. So let me come out of this one entirely. Now we are left with only one thing. We have to display the answer, right? So nothing but number of ways to make the amount using all coins. This will be present in dp of n and amount. So let me return here dp of n amount. Yeah, this is fine, man. So let me format the code once and let me hit the submit button directly. So I hope this works with the confidence I have hit the submit button directly. Let's see. Yeah, all the test cases are getting passed here. So whatever the code that we have written works absolutely correct for all the test cases, right? So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.